Good afternoon, students. Welcome to the first session on the topic that is concrete mix design. Uh, my name is Professor Chetan Limkar, working as assistant professor in civil engineering department of our college. I think this is my first session on your class, that is TYA and TYB class. That is why I think you're not familiar with me. So why I'm going to take your lecture, I think the question comes to your mind, sir. I think this is the lecture of composite materials, which is taken by Yasin sir. Right now he is dealing with the timber, correct? The part that he is teaching to you is nothing but timber. Introductory part he has covered up, and later on he will cover up the part of defects in the timber and whatever the remaining portion of the timbers. Okay, but I'm going to take the different part for you for your understanding. Again, we are revising this particular part, which is the most important from your competitive exams point of view. Okay. You are familiar with the coarse aggregate, the fine aggregates, then cement, then water. You are a little bit familiar with the particular ingredients. Okay. Now, these are playing vital role in making the concrete, in making that concrete durable, in making that concrete workable. Okay, so why I have taken this point, because this is the very important point. Whenever you are going to work on the field, you must have the knowledge about the concrete mix proportioning. Okay, it's not like that you have, yes, you know, everyone knows what is a concrete. Okay, but how we are going to make it, how we are going to prepare it, what are the applications of this particular word or this particular material in our real life. Okay, whenever you are doing some construction activities, what major role the concrete is going to play. Okay, again, before starting the session, let I remind everyone, concrete, it looks very simple. So what actually we are doing, we are just taking cement, coarse aggregate, fine aggregate, and the water, and we are trying to mix it, correct, in XYZ proportion. Okay, it may be for M5, M10, M15, M20, M25, M30, whatever the grades we are having. It may be standard concrete, it may be the nominal, it may be the high strength concrete. So whatever the type it may be. Okay, so what actually we are going to do, we are taking all the ingredients and we are going to mix it. Okay, but whether it looks simple, yes, it looks very simple, but the concrete is, again, on the other hand, the most complicated thing. Okay, it will affect the durability, it will affect the particular life of the structure. Okay, because if you mix it in a wrong proportion, if you mix it with the wrong ingredients, if you not follow all the rules and regulations that have been set up or being specified in your IS codes, relevant IS codes, then definitely concrete will hamper the structure and it will let down that structure. It will reduce the life of that structure or durability of the structure for more. Okay, so dear students, before starting the session, let's have some instructions for you, that if you feel any doubt regarding the topic that we are discussing right now, if you feel any doubt, if you have any doubt in your mind, please unmute yourself and you can directly ask me the question. Okay, or you can directly put it in the chat box also. You have the full liberty, you can ask me lots of questions. I'm expecting so many questions from you. Okay, unless and until you don't have the questions or the doubts with you, how the question will come to your mind. Okay, as I said earlier, concrete looks very simple, but it is not that much simple. Okay, I think previously you have studied concrete technology. In the concrete technology, you have studied the concrete, correct? You know what is a concrete. So how can you define the word concrete? Let's start with the discussion, and why I'm directly taking the point, directly using this particular IS 10262. Everyone knows for making a good concrete or for making the concrete in a proportion, we are going to use the Indian Standard Code, that is IS 10262 2019. If you use previous version, that is 2009, please upgrade yourself with 2019. Okay, this is the latest revision of IS code, IS 10262 2019. Nowadays, whatever the concrete mix designs are there, These are with respect to only IS 10262 to 2019. If you don't have the copy with you, I will put it in your group also. Okay, so don't bother about it. So concrete, if you see, it's a mixture of your coarse aggregates, fine aggregate, your cement, and the water. Can you able to define the role of each and every ingredient? Because such questions, these are likely to be asked in your competitive exams as well as in your interviews also. What is the role of cement? You are preparing the concrete, no doubt about it. Okay, what is the role of cement in a concrete? If somebody asks you why we are going to use the cement in the concrete, yes, I will check the chat box.
Binding.
Yes, it's a binding material. Correct, it's a binding having material. It is having some properties like silica, alumina, some ingredients are present. Okay, so if it's a binding material, then what is the role of fine aggregates? What is the role of coarse aggregates? Why we are using fine aggregate? Why we are using coarse aggregate? That is the next question from my side. What is the role of fine aggregates? If anybody can tell me why we are using. Why we are using the fine aggregate? What is the role of fine aggregates? Okay, if you don't have the answer, okay, to pour the spaces. Right. Okay, language is a little bit wrong, but your answer is correct. Okay, so to fill the material, actually fine aggregates play a role of filling. Okay, filling the gaps. Okay, so fine aggregates we are using as a filling material, and coarse aggregates we are using to give the strength to that particular ingredient, that is your concrete. Okay, so coarse aggregate is for giving the strength, your fine aggregates is for filling purpose, and your cement is used for the binding material. Okay, now the water, whatever the water we are using in the particular concrete, whether we can use non-potable water, can we use some wastewater in the given concrete? If you want to cast a concrete, you have to use the domestic, whatever the drinking water. Okay, whatever the drinking water, that is the pH lies between 6 to 9, and all other physical properties as per IS 3025. Okay, so drinking water we are using, correct? So whatever the concrete we are going to mix it, we have to mix it in a proper proportion. It may be used for footing purpose, it may be used for beam, slab, or any other structure, correct? So there are some guidelines which are given in your IS 10262 2019. Okay, so there are all the guidelines which have been there. If you see this particular IS code, some rules and regulations they have set up for you. Okay, then IS 269 2015 for the OPC cement. Now everyone knows what is the meaning of the word OPC, that is ordinary Portland cement. IS 383 2016, this is the latest revision. Again, if you don't know, please go in detail about this. That is IS 383 2016, that is for the specification of coarse and the fine aggregates. This is the second revision, latest revision that we have. Then IS 456, that is for the code for practice for plain and reinforced concrete. Okay, then all other subparts are there, which are for, some are for your admixture chemical, or it may be the mineral admixture, and all that things. Okay, so in the concrete, whenever you are going to prepare the concrete as per IS 10262, okay, you have to follow some rules and regulations, or you have to follow whatever the steps which are given in this particular IS code. Okay, now one more thing I'm going to share with everyone additionally. I think some of you have completed the diploma and they know what is the rate for making a concrete. Okay, now we're dealing, every day we're dealing with so many consultancy projects in our college only. Okay, that means we are giving the mixed designs to the different clients. It may be the PWD, ZP, private contractors and all that. Okay, we are receiving their material, we are going to test their material, we are going to test their all the physical properties or mechanical properties of the material, and we are going to give them the concrete mixed design. Okay, and this mixed design is the cost of doing this process or completing this process is around 30,500, I think around 15,000. Okay, so if you have a very good hand in preparing the concrete mix design, again, it will help you to give your bread and butter. That is why I have directly incorporated this particular topic, that is concrete mix design. Okay, if you have a good hand on how to cast the concrete, what are the things that you require to understand for the preparation of the concrete, how it is being prepared. Okay, it will help you a lot. It will help you a lot to understand all the concepts which are relating with the concrete mix design. Okay, so rather than discussing this IS code, the steps are there. Okay, I will show you one sample report that we are preparing and we have done it for one of the project site. Okay, I think my screen is, whether it is visible to everyone? Yes. Are you able to see the screen? It's a Word file that I have opened. This is just required for the concrete mix design. Okay, this is just required for the concrete mix design. Now, along with this mix design, I will also give you some highlights about the questions which are asked previously in the competitive exams. Okay, in the competitive exams. Okay, so you know this word M40. Okay, I will use the pointer. You know this word M40. So what this M stands for, what this 40 stands for, what is the grade, what is the meaning of this word grade, grade designation. What is meant by the word grade? Can you able to define it? What is grade? Every day you are using that language. Sir, आम्ही M20 ग्रेडचं डिझाईन तयार केलं, आम्ही M15 ग्रेडचं डिझाईन तयार केलं, M20 ग्रेडचं कॉन्क्रीट तयार केलं, मिक्स डिझाईन तयार केलं. What is this grade? Grade designation. How can you define this word?
Sir, here M40 in M is grade, no?
Can you repeat? Hello? Can you repeat the answer?
In M40, M is the grade of the concrete.
M stands for the mixed proportion and 40 is nothing but the characteristic strength, or we call it as the compressive strength at the end of 28 days. Okay. So this question again, so many times in the interview they have asked, what is M40? M stands for the mixed proportioning and 40 is nothing but the characteristic strength, or you can call it as the compressive strength of the concrete, which is taken at the end of 28 days only. Okay. So grade is nothing but the strength of concrete. It deals with the strength of concrete, characteristic strength. Now again, the second definition comes to your mind. Sir, what is characteristic strength? It is that strength below which not more than 5% of the test results are expected to fall. Correct. In the SOM, you have seen that stress strain curve, correct, limit of proportionality, ultimate yield load, then ultimate load, then breaking load, all that part you have studied, and there you gone through this definition, characteristic strength of the steel material. So what is characteristic strength? It is the strength of the material below which not more than 5% of the test results are expected to fall. म्हणजे काय? Sir, I know the definition very well, but how can I define? How can I understand the concept actually? Characteristic strength. So you are going to test the samples, correct? On 3 days, you are going to cast 3 samples. On 7 days, for 7 days, you are going to cast 3 samples. For 28 days, you are going to cast 3 samples, correct? So when suppose I'm going to test the concrete cubes for the 7th day after completion of the 7 days curing. Okay, so I will check whether there is variation between all 3 cube results. If there is variation, what is the limit? Okay, what is the limit? Then type of cement that we are using, that is OPC 53 grade conforming to IS. Okay, It may be IS 269, it may be IS 12269. There are, I think, three different IS codes we have to use for your OPC grade cement. Okay, IS 30, OPC 33, 43, and 53 grade cement we are using. Nowadays, 33, no one is going to use. If you search in the market, you will observe only OPC 43 and OPC 53. They are used widely. Okay, they are used widely. Rather than using OPC 43, again, I will prefer OPC 53 grade because the strength is more. Okay, the strength is more. Then the maximum nominal size of the aggregate. How can you define this word, maximum nominal size? See, there should be very clarity between the concept that you are teaching. Can you able to define this word? What is the maximum nominal size of aggregate or nominal size of coarse aggregate? So there are two words, nominal size and maximum nominal size of the aggregates. I have prepared this table, whatever the data that has been there in our IS 10262 2019. For one of the client, we have prepared this mixed design. But just for the understanding purpose, I am explaining each and everything. Okay. तुम्ही सीव एनालिसिस करता बरोबर आहे थोडंसं मराठीत. इफ यू फील कन्व्हिनियंट इन मराठी यू कॅन ऑल्सो टेल इन मराठी ऑल्सो. ठीक आहे. सो तुम्ही मिक्स डिझाईन करायचं असेल किंवा त्याचं फिजिकल प्रॉपर्टीज चेक करायचं असेल तर व्हेरी इम्पॉर्टंट यू हॅव टू गो द ग्रेडेड, यू हॅव टू गो फॉर द gradation of coarse aggregate as well as gradation of the fine aggregate. You are going to determine the value of the fineness modulus. हा एक नावाचा कन्सेप्ट तुम्ही फाइंड आउट करता, एफएम ची व्हॅल्यू फाइंड आउट करता. ठीक आहे. मग नॉमिनल साइज ऑफ कोर्स ऍग्रीगेट, मॅक्सिमम नॉमिनल साइज ऑफ कोर्स ऍग्रीगेट ज्यावेळेस तुम्ही सीव अनालिसिस करता त्यावेळेस मी थोडीशी हिंट देतो. तुम्ही याचा आन्सर मला मे बी इन आवर नेक्स्ट सेशन यू कॅन गिव्ह मी द आन्सर. व्हॉट इज द डिफरन्स बिटवीन द नॉमिनल साइज अँड मॅक्सिमम नॉमिनल साइज. आय विल जस्ट गिव्ह यू द हिंट. ओके. सो ज्यावेळेस तुम्ही हे ग्रेडेशन करत असताना दोन गोष्टी होतात. पहिली गोष्ट, द मटेरियल इज पास थ्रू द सीव. इट मे बी एनी सीव, 25 mm sieve, 20 mm sieve, 10 mm, 12.5 mm sieve. The material is going to pass through the sieve and some material is retained on the sieve. Okay, I have just given you the hint. Some material is get passed through the sieve and some material is get retained on the sieve. So please link this concept with the nominal size of coarse aggregate and maximum nominal size of coarse aggregate. Now I have given you the hint. Please search on it. Do some study and tell me the definition. What does it indicate? Maximum nominal size. Okay, it is 20 mm. That is the question for you. Okay, for our next session. Then exposure conditions. Now in Maharashtra or in India, we are having so many different conditions like mild, severe exposure, whatever the exposure condition. Exposure conditions are what? At what condition your concrete is get exposed. That means maybe in the summer season, temperature is 40 plus. Maybe in the rainy season or maybe in the winter season, the temperature is 10 degrees, 15 degrees. So at what temperature condition the concrete is get exposed? Exposed म्हणजे काय? कॉन्क्रीट कुठलं कुठलं वातावरण सहन करतंय. कारण नेहमी आपल्याकडे वातावरणात बदल होत राहणार आहे. कधी उन्हाळा आहे, पावसाळा आहे, हिवाळा आहे. टेम्परेचर रेंज वेगवेगळे असणार आहे. 15 डिग्री असू शकतं, 20, 40, 42 डिग्री असू शकतं. ठीक आहे. मग हा जो काही एन्व्हायरमेंटल चेंजेस ऑकर होतात त्या एन्व्हायरमेंटल चेंजेसचा तुमच्या कॉन्क्रीट वरती काय इम्पॅक्ट होतो. ओके, दॅट इज द एक्सपोजर कंडिशन. किंवा तुमचं कॉन्क्रीट हे कॉन्स्टंटली इट विल रिमेन अंडर दी वॉटर. सपोज तुम्ही अंडर वॉटर कन्स्ट्रक्शन करताय, ट्रिमी पायपिंग मेथड यूज करता तुम्ही त्यासाठी. मग अंडर वॉटर मध्ये माझं कॉन्क्रीट कॉन्स्टंटली इट विल रिमेन इन वॉटर. त्या केसमध्ये तुमचं कॉन्क्रीट कुठे एक्सपोज होते? इट इज एक्सपोज टू वॉटर ओनली. If you take the example of some bridges, piers जे portion असतात, some portion of the piers it is in water and some portion is exposed to direct sunlight. Okay, so again concrete is same but the exposure environmental conditions are different. So again you need to study the exposure condition at for which exposure condition the concrete is get exposed. Okay, because there is daily variation in the temperature, seasonal variation in the temperature. Okay, maybe your concrete remain in contact for a longer time with the water. It will remain in the dry condition for a longer time. The conditions, exposure conditions are totally different according to the site or according to the construction conditions. Okay, again, you have to focus on these exposure conditions. Workability, you know this concept. What is workability? Okay, there, and how we are going to test this workability on site. Okay, it may be the slump cone test, it may be the compaction factor test. Okay, it may be the VB consistometer test. So there are several methods to check the workability. What is workability? Can you define it? What is workability? Can you define it? Please tell me the definition. I think some definition take which is given in MS Shetty book you have studied. The ease with which we can place, we can pour, or we can compact the concrete, that particular point or the portion of the concrete or the stage of the concrete, we called it as the workability. The easiness of placing the concrete, the easiness of compacting the concrete, the easiness of pouring the concrete in one of the structure. Correct? So that point, that particular portion, we called it as the workability. Okay, it's not directly relating with the strength, as you have put up in the chat box. Okay, Snell, workability is not directly equals to the strength. Workability equals to the easiness of placing the concrete. Okay, easiness of placing the concrete. Again, I am repeating my words. It is the ease or the easiness of placing the concrete in one of the structure. It may be column, beam, slab, any structural element. How easily you can place the concrete, how easily the concrete gets compacted. So that nature or that behavior of the concrete, we called it as, we consider it in terms of the workability. Okay, so workability 75 mm. Here it is, one sample is there. What does it reflects? If the workability, the value, slump value is 75 mm, what does it reflect? Whether it's a highly workable concrete, whether it is a low workable concrete, or whether it is having medium workability. And for which structure this value is suitable? That is another question. See, this question is asked again in your competitive exams many times. They will give you the slump value. Suppose it's a 120, and they will directly ask you the question, if the slump value of the concrete is 120 mm, so what is the nature of the workability? Whether it's highly workable, whether it's low workable, whether it's medium workable. Or directly they can modify a little bit. What is the suitability of the concrete having 75 mm slump? Whether we can use it for road construction, whether we can use it for building, that is column construction, whether we can use it for footing, whether we can use it for your slab. So for which structural element this value suits more? Okay, so such type of questions they are going to ask you in the competitive exams. So what are the points that I'm telling now? Please try to remember it. Okay, my ultimate motto is to teach you the mixed design, the basic fundamentals of the mixed design, as well as give you some highlights or some exposure for the questions which are been asked previously in the competitive exams. Okay, so you will be prepared more for this. Then degree of site control or the methods of placing the concrete. Okay, methods of placing the concrete. Now you are going to place the concrete. Either you are using the pumps, that is pumpable concrete, or it's a non-pumpable concrete. So what are the rules and regulations? Which factor you consider for the pumpable concrete? Which factor you are considered for the non-pumpable concrete? Up to what height we can pump the concrete, or we can lift the concrete from one place to the other place? Okay, so that are the few questions again that comes to your mind. Methods of placing the concrete. Okay, then there are, for placing the concrete there are so many methods. Okay, maybe pumpable, non-pumpable, you can select some tubes. Okay, for a placing of the concrete in the structure. Then degree of site control, whether it is good, whether it is excellent. In almost in all cases we prefer the good site control. Okay, degree of site control, that is in a healthy environment and with all the amenities, where with all the facilities, with all the availability of the materials, where casting the concrete, the site conditions are extremely favorable. Okay, then type of coarse aggregate. Again, there are a number of questions on this point. Crust angular aggregates. Now you tell me which aggregates are the best suitable for the construction work. rounded shaped, angular, gap graded, or uniformly graded aggregates. Which aggregates are more suitable, or which aggregates you will prefer, whether you will go for rounded, whether you will go for angular, whether you will go for the crushed angular or some flaky particles, some elongated particles. What is your thought on this?
Angular.
Angular. Okay. It must be crushed or not? It's angular, that is okay. But it must be angular and crushed coarse aggregate. That is, I think all the aggregates are now from the that is crushing plants. So all these aggregates are crushed, but angular aggregates, that is the correct answer. Why not rounded shaped aggregates? Why we not prefer?
Voids राहतात.
Voids
जर
are
circular.
but voids is the one factor. Any other factor? Okay, first is void, second is the again strength parameter. Rounded shaped aggregates, crushed angular aggregates. Okay, voids is I think the most important factor for us, considering the voids, and again binding is also one of the factor that we need to consider. Okay, though cement plays a vital role, cement is responsible for the binding, but whether we are using the rounded particles, whether we are using the crushed angular particles, again the binding will get affected. Okay, so that is why we prefer the angular crushed aggregates in our concrete mix design. Okay, and maximum cement content, again with respect to IS 456, we are having the, that is in table number 5 of IS 456 2000, we are having the table which indicates or which will give you the value of maximum water cement, that is maximum cement content, what is the maximum water cement ratio or the minimum water cement ratio that we need to consider. Okay, so for any mixed design, I can say the cement content should not be more than 450 kg per meter. That is more than 9 bags. It should not consume. Okay, 450 kg means 9 bags of cement. Okay, so any concrete mix design, generally it may exceed in some of the cases. Otherwise, there are few exceptions for that, but in most of the cases, the maximum cement content should not be more than 450 kg per meter cube. You go for, I think that this value is most suitable for up to M30, M40 also. Okay, your cement content should not go beyond 450 kg per meter cube. 450 म्हणजे 9 बॅग सिमेंट. ठीक आहे, कोणी सांगू शकतं M20 ला किती बॅग सिमेंट लागतात, M15 ला किती लागू शकतात, M20 ला, M15, M25 ला मे बी मिनिमम सिमेंट कंटेंट सांगू शकता, कमीत कमी किती लागलं पाहिजे? I think in IS, I think in concrete mix design, you have gone through that table of IS 456, table number 5 of IS 456 2000. Okay, which will give you the value of minimum cement content, maximum cement content, and the water cement ratio. Okay, so in any case, it should not exceed 450. Just remember, because we are only using with the residential, for the residential purpose or for the commercial purpose, we are using the concrete M20, M30, M35, M40 grade. And for that, I don't think anyone will exceed the cement content beyond the 450. Okay. Then cement used, it may be any type, any company cement, Ultratech, Birla, JK Super Cement, Chettinad, any cement you can go, which is a confirmation with the IS 12269. As I told you, this is for OPC 53. Huh? This IS code is suitable. It is just for IS OPC 53 grade cement, IS 12269. For 43, I think IS, I just forget, 269 is there for that different, another is there. Okay. So again, you have to remember the which IS code is relevant with the grade of the cement. Okay. Specific gravity of cement. Generally, it is lies in the range of 3.10 to 3.15. 3.15 is the standard. Do you know the specific gravity of PPC cement? How can we determine the specific gravity of cement? What is mean by the word specific gravity at first? How we are going to determine the specific gravity of cement? That is the second question. And what is the specific gravity of PPC cement? Sorry. We're having 3 minutes left to conclude the first session. In the second session also, we will continue our discussion. So please rejoin the session using the same link. What is the reason? What is specific gravity, and what is the specific gravity of PPC cement? In your own language, you can tell. Because not in every case, again, please remember, not in every case, the specific gravity of cement remains as 3.15. This is the standard value. Okay, this is for OPC cement, but whether it will remain constant in all types of cement, my answer is no. Okay, it will definitely change. So specific gravity of maybe PPC is up to 2.95 to 3, up to 3.5 also at some 3.05 also at some extent. Okay, in some cases, but it will not remain constant everywhere. Okay, yeah, density. You are going to determine the, you are going to ratio of the unit mass of the material to the mass of the water. That is the ratio of the specific gravity. You in that way you can define the specific gravity. Okay, so specific gravity of PPC cement, it is always going to lie in the range of 2.95 to 3.05. Okay, it is not exactly remain as 3.15. You have to check it. You have to check the specific gravity of cement. How to check it? Which instrument you are going to use to check the specific gravity of cement? Tell me fast. Which instrument you can use to check the specific gravity of a cement? Which instrument you can use to check the specific gravity of a cement? Yes, if you get the answer, please tell me which instrument we are using to determine the specific gravity of the cement. Lee Chatellier's flask mold, picnometer. First answer is little bit correct. Lee Chatelier flask method. Okay.
Lee Chatelier apparatus.
Yeah, that is one Lee Chatelier's specific gravity bottle, we called it as. Okay, one bottle is there, Lee Chatelier's bottle, we called it as, and using that you can determine the specific gravity of cement. Picnometer is used to determine the specific gravity of fine aggregates. Okay, one student has written the answer as picnometer. Picnometer is used to determine the specific gravity of fine aggregates, not the cement. For determining the specific gravity of cement, you have to use the Lee Chatelier specific gravity bottle. There is one bottle, we call it as. Okay. Then chemical admixtures, I will take this point in my next session. Dear students, please remember, less than a minute is left to conclude this session. So please, everyone rejoin the session using the same link after the end of this first session. Okay, and rejoin immediately. Don't take so much time, so that we can discuss the further more things regarding the concrete mix design.